Hi everyone, welcome to our presentation on profile-based electronic learning, content aggregation and delivery system using self-learning satisfaction index of user as feedback. Presentation by Professor Nitin V Pujari, Vinay S K and Sucharitha P from PES Institute Institute of Technology, Bangalore, Karnataka, India. Our agenda for this presentation is as follows. We start with the introduction, followed by architecture and overview of the proposed system. Then knowledge-based organization, weighted score assignment, determining learner comprehension index and content aggregation, followed by question generation, self-assessment, feedback processing and content delivery. Every human entity born in the universe will possess distinct characteristics, some inherited and other their own. Human beings, when compared, mainly differ in their biological, chemical and psychological characteristics. These differences make human beings to receive, perceive, interpret and store information differently based on their cognitive abilities. Knowledge resources generally are not organized based on the cognitive abilities of an individual. Individuals with lesser cognitive abilities will find it difficult to understand the contents presented in the knowledge resources, which have higher comprehensibility. On the other hand, people with a higher cognitive ability will not find a knowledge resource with lesser comprehensibility useful. It is obvious that the learners have different cognitive abilities, and therefore there is a need to identify learning abilities of the learner and present the content in which he or she would feel appropriate or congruent. Learning abilities include the ability to understand, familiarity with the concept and prerequisite knowledge. The proposed system can be implemented in 3 steps: self-assessment, knowledge progression and assimilate new concept. In the self-assessment stage, learner is expected to have some understanding of the domain or subdomain during self-assessment. The proposed system encourages different approaches for automating the generation of question bank based on the ability of the user. The learner evaluates and gauges the level of knowledge and gives feedback to the system for the next step of actions. Second step being knowledge progression. The learner assesses his conceptual knowledge from step 1. Based on the assessment, learner can reduce the self-learning satisfaction index. If the self-learning satisfaction index of user is high, learner can concentrate on a different concept or else can decide to increase his expertise in the chosen concept after comparing with the performance index generated by the system. In the assimilation of new concept stage, the learner can assimilate new concepts in the chosen domain. In this case, learner selects the concept in which learner is a naive. The proposed system treats the learner as a beginner. Initially, an introduction to the concept is presented. The learner attempts to understand the concept. On success, learner can proceed with the knowledge progression, or else the system will suggest prerequisite concepts. Learner can proceed with the knowledge progression or assimilation of the prerequisite concepts. The system we are proposing uses profile as the basis for content selection and assessment. All the result of activities with our system, such as feedback, will be recorded in the profile. Profile of a user can be defined as the information of the user, which will help us in fine-tuning the content for learning. In our proposed system, the profile of a user is not constant. For every learning process, a profile is necessary. The profile must consist of a specification of information related to the domain and subject. The proposed profile-based system differs from the other existing system in such a way that our system takes into consideration multiple profiles for each user, one profile for each learning of a new domain. Sources for the content aggregation and delivery are collected and organized in a container called as the Universal Knowledge Base. The Universal Knowledge Base has all the resources that are required to present the appropriate content. These resources include the following. We have textbooks, links for portals and discussion forums, research articles, presentations, and universal knowledge classifications. All of these resources are considered as the knowledge resource. Each of the knowledge resource is used for a specific purpose at different stages. For example, links to portals and discussion forums are used to generate questions for self-assessment. The proposed system can be implemented by logically sequencing the following steps. First one being how to organize knowledge base, followed by weighted score assignment, determining learner comprehension index and content aggregation, question bank generation, self-assessment, feedback processing, and content delivery. Upon the organization of universal knowledge base, each of the knowledge resource will be assigned a score in the weighted score assignments tab. This score helps to filter out the contents that are appropriate for the learner. In the third step, where the learner comes into picture for the first time, analysis of the learner is made to find the best available contents for the learner. It is done on the basis of comprehension index of the learner. Learner is asked to express knowledge of the content which learner wishes to learn in textual form. From the paragraph, comprehension index of the learner is determined. Based on this analysis, content from the knowledge resources are aggregated. From the aggregated content, a set of questions are generated to assess the level of understanding of the user. The proposed system differs from existing systems in a way that assessment is made by the learner. This helps to determine the self-learning satisfaction index of the learner. Based on this index, used as feedback, further assessment and content delivery is made. This slide shows the architecture of the proposed system. The first two stages explained in the previous slide is completed before the learner comes into picture. The detailed explanation of this diagram is described in the subsequent slide. In this figure, you can observe that user is entering the paragraph, then the keywords are extracted, followed by domain matching and content aggregation. From the aggregated content, we are generating questions. Using the same set of questions, user assesses himself in the self-assessment stage and gives feedback to the system. The feedback processing and content delivery subsystem will take these feedbacks into consideration and allow the users to proceed with knowledge progression or assimilation of the new concepts. As explained in the previous slides, we are using profile as the basis for content selection. The usage of profile is done in two stages: profile creation and profile evolution. In the profile creation stage, the user is going to enter details such as achieved proficiency in the domains subject in which he is interested. These will be treated as static. In the profile evolution stage, the evaluation of user is done and the profile is updated. For each learning process, we recommend the following fields. The fields are questions, performance index, and recommendation. The questions field is the number of questions generated for the user entered paragraph. And the performance index is the number of questions that are answered by the user. This is the field where feedback of the self-assessment is recorded. The recommendation field is the number of questions to be answered by the user based on the initial profile. This is the field where the system recommends performance index based on the profile of the similar users. In addition to the assessment through question answering process, the user can select the required proficiency in the concept. The selection of proficiency should be made before the self-assessment stage. The value of recommendation field changes with this selection of proficiency. After each assessment, feedback of the user is recorded in the profile for the further learning process.
Universal Knowledge Base has classified set of domains. This keyword-based classification is done using a set of qualifiers. Each domain encompasses a set of subjects. Subjects are assigned to a domain based on the keywords it represents as a subset of domain-based keywords. Each subject has a particular set of knowledge resources. Each knowledge resource has a set of keywords representing the knowledge. Further knowledge resources are organized in terms of concepts, each one covering a part of the knowledge. Concepts are presented as set of multiple paragraphs. Each paragraph represents a portion of a particular concept. The entire universal knowledge base can be organized hierarchically as shown in this slide. First level, domain. Domains can be obtained from the available knowledge sources such as Wikipedia, DBpedia, etc. We are using the available classification from the sources. Example for a domain could be computer science. In the second level, we have subject. Subject covers a portion of the domain. Example subjects that are under the computer science domain could be data structure, operating systems, etc. Subjects may span across multiple domains. For example, microcontrollers come under both computer science and electronics domain. Third level, knowledge resource. Subjects are described in various knowledge resources. Knowledge resources are the source of content for learning. Fourth level, concept. Each knowledge resource presents the content of the subject in terms of concepts. Concepts are similar to chapters in the textbook. Paragraph. Concepts are expressed in different paragraphs. Each paragraph is a distinct section in a concept. The proposed system uses weighted scores to choose contents for aggregation and delivery. When the universal knowledge base is organized, scores are assigned. Assignment of scores is done based on the coverage factor, which can be defined as the relative amount of knowledge a particular item covers with respect to a domain it belongs. From the coverage factor, scores at each level can be assigned as follows: subject score, knowledge score, concept score, and paragraph score. In addition to assigning scores based on coverage, knowledge resources are further classified to distinguish between the levels of specialization or the level of difficulty. The classification is as follows. First, textbooks, which are used for regular reading. Second, reference books, which are used for obtaining deeper knowledge with much elaborated contents. Third, research-oriented books, which are for highly specialized reading. The learner demonstrates knowledge of the concept by entering text related to the concept. The model extracts all keywords from the text. Based on the extracted keywords, the domain to which the concept belongs to can be inferred by referring to the universal knowledge base. A score is assigned for the paragraph. These scores together are used to determine the index called comprehension index of the user. The comprehension index is used to determine the proficiency of the learner in the context of the concept. The scores are assigned based on two factors called strength and weight. Strength measures the breadth-wise knowledge and weight measures the depth-wise knowledge. The whole process of learner analysis and content aggregation proceeds in the following stages. First stage, domain filtering. Second stage, subject filtering. Third stage, knowledge resource filtering. Fourth stage, concept filtering. And the fifth stage, paragraphs filtering. The aim of domain filtering is to select a domain where the learner written concepts belongs. It is done with the help of strength and weight factors, where the domain strength is equal to the number of domains covered divided by the total domains in the universal knowledge base. Lesser the value of domain strength implies that the textual content given by the learner falls in a domain. Larger the value, higher is the number of domains covered. In that case, the model asks the learner to rewrite the concept. The process is repeated until the domain strength asserts single domain coverage. The above mentioned process is not expected to repeat because the entered content may not span across multiple domains. Then the domain weight is calculated for each domain as follows. Domain weight is equal to the number of keywords covering the domain divided by total keywords in the content of learner. The model selects the domain which has the highest value. It is guaranteed that only one domain will have largest weight because the domain strength is less. Similarly, subject filtering, the knowledge resource filtering and concept filtering are done using the same formula. For subject filtering, formula changes to subject strength is equal to the number of subjects covered divided by the total subjects in the domain. Subject weight is equal to the number of keywords covering the subject by total keywords in the content of learner. For paragraph filtering, The model uses a threshold value which is the average paragraph weight. Threshold is equal to the summation of paragraph weights divided by the number of paragraphs. The proposed system considers paragraph whose paragraph weights are above the threshold. The content that is considered for question generation and later delivery is an aggregation of paragraphs selected in the previous stage. Once the domain and the subject are inferred, the model fetches all questions related to the concept which the learner wishes to learn from the question resources which are associated with the subject. The question resources include question and answer portals and discussion forums. To generate questions, we are using the internally aggregated content. From this content, all keywords are extracted. Questions will be fetched from all the available question resources. The obtained questions for the user is an aggregation of the questions containing the keywords from all question resources. It is very likely that the same question will exist in multiple question resources. Therefore, it is necessary to filter the questions obtained from each question resource. The model follows a two-step filtering process. Type 1 filtering. Questions which contain the same words are redundant. All questions which have the same form, that is, contain the same words, are eliminated. Questions which do not contain the same words may also have the same meaning. Therefore, redundancy still exists in the obtained question set. To eliminate this, the model goes for the second step of filtering. Type 2 filtering. Questions which are semantically equivalent to each other are redundant. The model eliminates all questions which are semantically equivalent. At the end of this two-step filtering process, we obtain the question set which contains questions which are distinct from each other. The learner is presented with the questions which were generated in the question generation phase. The learner attempts to answer the questions. The learner evaluates himself by calculating the user self-satisfaction index. User self-satisfaction index is equal to the number of questions answered correctly divided by total number of questions presented. The user self-satisfaction index of the user for this concept is archived by the model. The learner has to determine if he is satisfied or not satisfied. This decision is a subjective measure and varies between users. The self-satisfaction index of the user is taken as a feedback. Feedback processing is performed as follows. The first possibility is the learner is satisfied. The learner can switch to a new concept and start with either knowledge progression phase or assimilation of new concepts. Here there are two scenarios to be considered. First, if the learner wishes to start the knowledge progression phase of a different concept, the learner has to express his knowledge of the concept in textual form, answer the questions presented to him, calculate the user self-satisfaction index and proceed with the knowledge progression phase if he is not satisfied, or switch to assimilation of new concept. The second scenario, if the learner wishes to start the assimilation of new concept, he has to specify the concept. The model determines the prerequisite knowledge required. This is determined by traversal of the global knowledge base. The traversal starts from the root node in the tree till the required concept node is found. All siblings of this concept node which appear to the left of it and are at the same level are the required prerequisite concepts. The model evaluates the achieved prerequisite index, the API of the user for this concept. The achieved prerequisite index of the user is the average of the user self-satisfaction index of each of the prerequisite concepts. An API of 5 is considered the minimum score required to proceed with the assimilation of the new concept. A second possibility is the learner is not satisfied. That implies the user self-satisfaction index is low. The user is taken into the knowledge progression phase and presented with the content which was aggregated for the user. The user is expected to learn the concepts presented to him and then express his understanding of the concept in a textual form. The user entered source is evaluated and the user comprehension index is evaluated. The user comprehension index of the user is expected to increase. If the user comprehension index for this concept has not changed, the user is presented with the same concept till the user comprehension index of the user increases. Else, if the user comprehension index is increased, questions which are generated for the advanced concept are presented to the user. Self-assessment of the user takes place. The user evaluates his user self-satisfaction index and based on it, he can proceed with the knowledge progression or assimilation of new concept. Thank you.